I'm Anil Kumar, and here we have a similar question which we dealt with in question number 5. The question is, for sine theta equals to minus 12 over 13, where theta is between 0 and 360 degrees, draw a sketch for theta and determine tan theta. I'd like you to pause the video, answer the question, and then move on to the next question. Now here is my suggestion. As we discussed earlier, when theta is between 0 to 360 degrees and sine theta is negative, we are actually looking into for two different cases. So let's draw these two on a coordinate plane. Now when we say sine theta is 12 over 13, what does it mean? It really means that y value is minus 12 and the radius or the hypotenuse of the right triangle is 13. So one triangle could be formed with this minus 12, right? And the other is 13. So maybe kind of like this, right? So that is the point. So we have a point in quadrant 3. As you know, sine theta is negative in quadrant 3. Now for minus 12, this value of plus 13 could also be in quadrant 4, right? Here also sine theta is negative. So we have two cases, right? This is case 1 and this is case 2, right? Now we find that sine theta could be in quadrant 3 or in quadrant 4. Now in either case, what is the value of x, right? So let us say this is a point P with x value not known, x1, but y value is minus 12. In this particular case, let's say this point is Q, where x value is not known, let's say x2, but y value is minus 12, correct? That is how it is. But in addition, we know that the hypotenuse is 13 in both the cases. Now based on that, and then we know this is a right triangle, right? So we can apply the Pythagorean theorem and find the x value, this, right? We know 12. So we have x value from Pythagorean theorem. We can say x is equal to, we know x square is equal to 13 square minus 12 square, correct? So x is equals to square root of 13 square is 169 minus 144, correct? Which is indeed 25. So that gives us a value of 5. So we get value of 5. Now since we are here, this is indeed minus 5, correct? So we get x1 as minus 5. So in this particular case, the coordinate point is P as minus 5 minus 12. Here we'll do the same calculations, but the point will be positive 5, right? Since it is pointing towards a positive x value. So the Q point here is positive 5 minus 12, correct? So that is how these 2 points are different. Remember one thing, whenever you do square root, you have to do plus and minus, correct? Plus and minus x squared, because negative 5 squared is also positive, right? So since we are in quadrant 3, we'll select minus in this case. Since we are in quadrant 4, we'll select positive 5 for x in case 2. Now we can find tan theta. So here in the first case, tan theta should be what? Here tan theta should be equal to ratio of y to x, that is minus 12 over minus 5, correct? So that is the value, 12 over 5. Tan is positive in quadrant 3, it makes sense. In this case, tan theta is how much? Tan theta is minus 12 over 5. It is negative, do you see? Negative 12 over 5. In quadrant 4, we know tan theta is negative. And so we get two different answers, right? So our answer here is in quadrant 3, tan theta is positive 12 over 5. And in quadrant 4, tan theta is negative 12 over 5. So there are two values for tan theta which we should be looking forward to, right? So that is how these questions should be solved. I hope you appreciate it. Thank you.